You know, when you think about the oil and gas industry, you picture these massive, sprawling networks of pipelines. We're talking trillions of dollars of infrastructure, all designed to move energy under some seriously intense conditions. It's an engineering marvel, really. But what if the single weakest link in that whole chain was about to get a complete reinvention? Well, today we're going to dig into a patent that does exactly that, introducing a material called Polyketone that's, well, it's a total game changer.
It's a great question, right? You see these giant steel pipes and you think, that thing's gotta be indestructible. But the real vulnerability, it isn't something you can see from the outside. It's hidden deep inside, right down at the molecular level of the materials that are supposed to be protecting everything. And that's exactly what brings us to the breaking point. We're talking about an incredibly hostile environment inside these pipes. You've got intense heat, and you've got these really aggressive chemicals, all mixing together to create this perfect storm that just chews up materials you'd think would last forever.
So here's the challenge in a nutshell. We're pushing the envelope now. We need to operate at higher and higher temperatures, sometimes up to 110 degrees Celsius. And the stuff we're moving, it's loaded with these aggressive chemicals called aromatic hydrocarbons. These are the exact conditions that cause traditional pipeline materials to just give up.
For years, the industry has really leaned on one key material to line the inside of these pipes, polyethylene. And look, it's been a workhorse, no doubt. But as the demands get tougher and the conditions get more extreme, its biggest weaknesses are starting to become a major, major problem.
Okay, so before we dive deeper, let's just quickly get on the same page. When we say spoolable composite pipe, we're not talking about a simple tube. It's this really sophisticated layered system. You've got that inner polymer liner, that's our focus today, then a super strong reinforcement layer, and a tough outer cover. The thing is, every single layer has to do its job perfectly or the whole thing fails.
Now, this is where it gets really interesting. You see the massive gap between what we expect from polyethylene and what we actually get under real-world stress. We expect a durable liner, but its strength just plummets. We expect a stable structure, but instead it swells up and gets soft. That's a process called plasticization. And maybe worst of all, we expect safe containment, but it actually lets hazardous gases leak right through it.
And hey, don't just take my word for it. This is the core problem, spelled out right in the patent. The material literally soaks up these hydrocarbons, swells up like a sponge, and its strength just tanks. This is the exact failure point that screamed for a totally new kind of solution. And now, that solution is here. This is where the story takes a turn, thanks to an amazing innovation from Hyosing. We're talking about a whole new class of polymer. It's called aliphatic polyketone, or as we call it, POK.
Now, POK isn't just a slightly better version of the old stuff. It's a completely different animal. It was engineered from the molecules up, specifically to thrive in those nasty conditions where polyethylene fails. Its unique structure gives it this incredible resistance to those harsh chemicals and allows it to hold on to its strength even when things get really, really hot. And let me be clear, this isn't just some theory from a lab. This is proven, patented technology. The patent itself is assigned to an energy giant, Aramco, and the material they tested is Hyosung's very own Polyketone. This is a real-world, commercially available solution that's been put through its paces and is ready to go.
So just how much better is it? Well, the patent gives us the receipts. It lays out these intense head-to-head stress tests. We're about to see the hard data, putting Polyketone directly up against the old industry standard, a material called PERT, under conditions that mimic the real world. Let's see what happens. Okay, first up, swelling. Remember, this is the thing that causes the liner to get soft and fail. This chart shows how much of those hydrocarbons the material soaked up after 90 days at 93 degrees Celsius. And wow, just look at that difference. Polyketone shows an incredible 75% reduction in swelling. It just doesn't absorb the junk that destroys it. All right, next, let's talk about raw strength, what engineers call tensile modulus. After being exposed to these brutal conditions, the standard PERT material, it's left with a strength of just 49 megapascals. Okay? Remember that number, 49. That's our baseline with the old tech.
And now, look at Polyketone. Even at a much higher temperature, 110 degrees Celsius, its strength is 330 megapascals. Let that sink in. That is nearly 7 times stronger while being almost 30 degrees hotter. This isn't just a little bit better, it's playing in a completely different league. And finally, and for a lot of people, this is the most important one, let's talk safety. This chart shows how much dangerous hydrogen sulfide gas, that nasty sour gas, leaks through the liner. Polyketone is just a way better barrier. It cuts that hazardous gas leakage by over 60%. From a safety standpoint, that is an absolute game changer.
So we've seen the data, and it's pretty clear. Let's take a step back and think about the big picture here. What does all of this incredible performance actually mean for the folks in the oil and gas industry?
The Polyketone advantage is really simple, but it's incredibly powerful. It means you can operate hotter, you can handle more aggressive chemicals, you can count on your liner staying strong because that swelling problem is basically gone. And most importantly, you run a much safer operation because you're stopping those dangerous gas leaks. This isn't just an upgrade, it's a whole new level of confidence. You know, what we're really looking at here is the creation of a brand new standard. For those really tough, high-heat, high-pressure jobs, the data from this patent makes it crystal clear. Aliphatic polyketone is the new benchmark for reliability, for safety, and for just pure, raw performance. The energy world is only getting tougher, right? The challenges are getting bigger. The emergence of a material like Hyosynth's Polyketone isn't just some neat science experiment. It's a direct solution to the problems of tomorrow. And that really leaves just one big question for everyone out there. Is your infrastructure ready for what's coming next?